one, we're going to graph the rational function f of x or y, and we're going to do this by hand. This is an introductory video, so we're not going to be using parent functions or anything like that. We're just trying to get the concept of the rational function. So basically, the graph of a rational function has two or more branches. So usually it looks something like this, or it looks like this. There's your two or more branches. Or it could be, if it's negative like ours is, I'll put that negative there. I like it better there. It would maybe look something like this instead, the green part. And then it could have more, and I do have a problem where it's more. But right now, let's concentrate on this one. So the first thing is we have to find the asymptotes, the vertical asymptote and the horizontal asymptote, because that's going to frame our graph. And then we're going to find some points and finish off the graph. So for the vertical asymptote, it's the easiest. It just means where it's undefined. That means you cannot divide by 0. So our denominator here cannot be 0. So if you solve for x here, x cannot be 2. So since it can't be that's where your vertical asymptote is, at x equals 2. Your horizontal asymptote is more conceptual. So it means as the value of x increases, as x gets larger and larger, what does my y value get closer and closer to? We're going to find an approximation. For example, if I plug in, say, 100, that's a pretty large x value as x increases. So you have negative 4 divided by 100 minus 2 is 98. And you think about it, that's very, if you look at integer values, that's very close to 0. Again, if you plugged even in a larger number, so if I plug in, instead of 100, I plugged in 1,000, that would be 998. So as it gets bigger and bigger, it even gets closer and closer to 0. So your horizontal asymptote is going to be y equals 0. And then what we're going to do is draw these lines. These are lines. Asymptotes are always lines. We're going to plot that and then just pick a few points and get the general idea of the graph. So we're going to plot y equals 0. And I usually use dashed lines because they're more like invisible lines. That's y equals 0. And then I'm going to plot my x equals 2, my vertical asymptote. It's like a translation of the axis. So this is your x equals 2. So we're going to start, this is your main point we're going to look at. We're moving it over. So I want to know what's going on this side of the graph of the x equals 2. Now, so let's plug in 3 and just see what happens when I plug in 3. If I plug in 3, I get negative 4 divided by 4 minus 2 is 2. Oh, 3 minus 2, right? So let me put a 2 here. 3 minus 2 is 1. So that would be negative 4. So at 3, we're at negative 4. All right. And let's plug in 4. If I plug in 4, I get negative 4 divided by 2, which is negative 2. So it would be here. Now let's plug in a larger number. So let's plug in 8. So if I go to 3, 4, 5, 6, 7, 8, where will we get? We get negative 4 divided by 8 minus 2 is 6. That's negative 2/3. So that would be right in there. And then just given that we not know what the graph looks like, it's a little curvy, has these branches. So this branch right here gets closer and closer to y equals 0 because as x increase, my y value is going to get closer and closer to 0. And this branch is going to get closer and closer to x equals 2. Now, let's look on this side of my x equals 2. So let's plug in 1. If I plug in 1, I'm going to get negative 4 divided by negative 1. That is 4. So at 1, we're at 4. These are symmetric. And then if I plug in 0, I'm going to get 2. And of course, then it just is symmetric. So you can plug in some more points. Let's plug in negative 6. You're going to get the 2/3 thing. So plug it in, and it looks like that. Gets closer and closer to 0. And also this branch here gets closer and closer to x equals 2. And that's it. Thank you. Have a nice day. Bye-bye.